Okay, today we're going to talk about solving systems algebraically. You did do this in Algebra 1, so it should be a quick, easy review for you. The problems are just going to be a little more involved than what you've had before. So first and foremost, let's talk about the two different methods that we have. The first one being one called substitution, and the other method is called elimination. Some books refer to this method as linear combination. So if you see it or hear of it, that is the same thing. Okay, now let's talk about the steps. First off, notice from the little graphic that I have is the first two steps are different in these methods, but once you get down to a certain point, everything's the same. Okay, so it's just a matter of how you start the problem off. So to begin with, in substitution, you want to pick an equation and solve for a variable. It doesn't matter which variable. Okay? And after you do that, you're going to plug or substitute, hence the name substitute, plug in the answer from step A of what you just did above. Okay, you're going to plug in that answer into the other equation, and this is where it's so important, because if you don't go to, you picked an equation here, so when you plug in, you got to plug into the other equation, because we're always going to have, remember, a linear system, what we talked about yesterday, is a two or more equations with two or more variables. So we're always going to have two equations that we're dealing with. So you picked one, solve for the variable, then plug that variable into the other equation. Now, from there, you're going to, at this point, you will be down to one equation with one variable. So you're going to solve that resulting equation. Okay, so you've solved it. Let's say that you solved this for y, you plugged into y in the other equation, and you were left with x. So then you solved it for x. And once you have solved it for x, you got x as a number, okay? You're going to plug in the value that you got from step C, which is this up here that we just did, and you're going to plug it into an original. You could be safe plugging it into the original equation. If you don't plug it into the original equation, then you might not. Um, you're just kind of working in the same in a circle if you've made a mistake. So plugging the value from C into an original equation, that would be the two equations that you started with, and solve. And that will give you the last variable. And last but not least, you want to write your answer as an ordered pair. Okay, we talked about yesterday when we talked about solving systems by graphing. Solving the system is finding the point of intersection. So just because we're doing it algebraically, they still intersect in a point, so we want to write that answer as an ordered pair. Okay? Now let's briefly go over elimination. I'm going to talk about the steps, and then we're going to show the different methods as we go through. If we have elimination, excuse me, and I have two equations, then this time, this is the method that we multiply an equation. Sometimes we have to do two. Multiply an equation by a constant to make A or B, actually the A's or the B's, fall out, in essence, to eliminate them. Now, what am I talking about when I say A and B? Generally, we're looking at an equation in this form when we use elimination. AX plus BY equals C. So I'm going to multiply it by a constant that's going to make the term, that variable, fall out, which is what the A's and the B's, if they fall out, that variable is going to fall out. Okay? And after you do that, you're going to multiply the equations by a constant to make the A or B's fall out. Then you're going to combine the equations to make the variable fall out. And actually I said fall out. Let's change this so that you'll understand a little bit better. Instead of fall out here, make A or B's opposites of each other. And you'll see as we go through. Okay? Multiply your equations by a constant to make A or B opposite. Then combine your equations to make a variable fall out. So when one variable falls out, you're left with the resulting equation with one variable, and then the rest of your steps are the same. So let's go look at this one. Now, it tells us what is the solution of the system. So we're looking at that point of intersection. And when I look at these, okay, my A's and B's, remember this is my standard form, AX plus BY equals C. All right, and I don't have anything that's going to be necessarily, well, I could. This is a 1, so I could multiply it by 2, and that would make it the opposite. So if we multiplied this equation by 2, then that gives me 2x. 3 times 2 is 6y, and 5 times 2 is 10. So that was step A. I multiplied an equation by a constant to make my A or B opposites. So now I have negative 2 and 2, and then I'm going to combine them. Negative 2 and 2 are eliminated. My x is gone. Negative 4 plus 6 is 2y, and 10 and negative 5 give me 5. And then, of course, we solve that resulting equation, and we get that y equals 2.5. So I have solved my resulting equation, and now I'm going to plug in the value from C into an original equation. So I'm going to plug it into the one that has x by itself. So I'm going to take my y equals 2.5. So I'm going to have x plus 3 times 2.5 equals 5. And 3 times 2.5 is 7.5. And so then I subtract 7.5 and I get x equals negative 2.5. So that was plugging in the value into the original equation, and then I solved it. So the last thing I want to do is write my answer as an ordered pair. Of course, x comes first, negative 2.5, comma, 2.5. And absolutely, if you prefer the fractions, you can write negative 5 halves, comma, 5 halves. That would be the same thing. All right, let's look at the next problem. Okay, we have a word problem. An online music company offers 15 downloads for $19.75 and 40 downloads for $43.50. Each price includes the same one-time registration fee. What is the cost of each download and the registration fee? So first and foremost, if you need to pause, if you need to read the question again, I'm going to jump right in. The first thing that you should look at, I like to look at, is what is the cost of each download? What am I looking for? So I'm looking for the cost of each download, and I'm actually looking for that registration fee. So what are my two equations? I have one company gives me 15 downloads plus that registration fee, and that one is $19.75. And then I have another company that gives me 40 downloads plus that registration fee, and that costs $43.75. No, excuse me, $43.50. So I have two equations and two unknowns. I have a linear system, and I actually have two variables that are already the same. So I'm going to take this top one, and I prefer to add instead of subtract. So I'm going to multiply everything by -1 just to make my life a little easier. So I have -15d minus f equals -1975. And so I'm going to combine these two. So I multiplied by a constant to make my coefficients opposites, and now I'm combining the two of them. And when I combine them, I'm going to get, so I'm combining these two. 40 minus 15 is 25d. 4350 minus 1975 gives me 2375. And then we divide by 25, and d equals 0.95. So that tells me, what does that tell me? Well, I'm solving the system. Let's go back and answer the question. So we have d is equal to 0.95. So now I have to go plug it back in to any equation, either one. So let's go plug it into, I'm just going to use the one with smaller numbers. Okay, so I'm taking this d value and plugging it into 15d plus f. So I have 15 times 0.95 plus f equals 1975. And 15 times 0.95 is 14.25 plus f equals 1975. How do I get rid of this? I have to subtract it. So f equals 1975 minus 1425, which is 5.5. So to answer the question, we have each download costs 95 cents, and the registration fee is $5.50. Okay, moving right along. What is the solution to the system? All right, we have, again, we're in standard form, ax plus by equals c. And if you notice, these two are already opposites of each other. So if they're already opposites, I'm going to go ahead and combine them. My y's will fall out. -2 plus 5 is 3x. -8 plus 20 is 12. So x equals 4. All right. And from there, I'm going to go plug it into, and again, it doesn't matter. If I have to solve for y, I'm going to pick the one that has a positive y. So I'm going to pick the top one. We're going to bring those together, and I'm going to have -2 times 4 plus 8y equals -8. That says -8 plus 8y equals -8. If I add 8 to both sides, I'll find out that 8y equals 0 and y equals 8. So the solution to my system is 4 Where are my students when I need them? Okay, 0 divided by 8 is not 8. 0 divided by 8 is 0. So the solution to my system is 4, comma 0. I don't have anybody here telling me to pay attention to what I'm doing. Okay, number 4. What is the solution? Okay, uh, I have done everything by substitution. Excuse me, by elimination. And to tell you the first example, just to go back and look at it real quick, okay? Whenever you have a variable here that has a coefficient of 1, as this x does, that's always a possibility to use substitution. If you do not have a coefficient of 1, I would not use substitution. I would use elimination. So looking at these, I don't have anything that's the opposite. And so I'm going to use elimination to solve this system. Okay, it does not matter which one. So we'll go ahead and pick let's eliminate, the x's. We make the x's fall out. So that means I'm going to take 3x, I'm going to go ahead and rewrite it. 3x plus 7y equals 15, and 5x plus 2y equals negative 4. Okay, so I'm going to multiply this by 5, and I'm going to multiply this one by negative 3. So when I do that, 5 times 3, 15x, 5 times 7, 35y, 5 times 15 is 75. 5 times 3 is negative 15. 2 times negative 3 is minus 6y. And negative 4 times negative 3 is 12. So now when I combine these, you will see that my x's will fall out. 35 minus 6 is 29y. 75 plus 12 is 87. And we're going to hope that 87 divides by 29 evenly. And it does. It gives me 3. So we multiplied by a constant to make our coefficients opposites. Then we combined our equations. We got one equation. We solved that resulting equation. And now I'm going to go back and plug in. Okay, they both this time have a positive y, so it really doesn't matter. I'll probably choose one with smaller numbers. So that gives me 5x plus 2 times 3 equals negative 4. We have 5x plus 6 equals negative 4. 5x equals, take the 6 over, means I have to subtract it. Negative 4 and negative 6 is negative 10. And x equals negative 2. So what is the solution of this system? It is an ordered pair of negative 2, comma 3. Now I haven't spent a lot of time on it, but I hope that you can remember, we've talked about this lots of times, that you can always check it by plugging in negative 2, 3 into both equations to see if it works. Okay, two special cases we need to talk about. So let's look at these. When I look at those, how do you want to do them if we do substitution? Let's do substitution since we haven't done that. This is a y, and so I'm going to move that x to the other side to solve that. Y equals x minus 2, and I'm going to take that and I'm going to plug it into the other equation for y. So I'm going to have 2x minus 2 times x minus 2, because that was my y, equals 0. So if we simplify that, 2x minus 2 times x is minus 2x. Minus 2 and minus 2 give me plus 4. 2x minus 2x. So I'm left with 4 equal to 0. Surely you know that's a false statement. And if I come down to a false statement when I'm working algebraically, especially solving equations, then I know that I have no solution. So you can use our symbol or you can write out no solution. Okay, look at the next one. I'm going to do substitution again because we haven't done much of it. Because I have a variable that's by itself, has a coefficient of 1. So if I take the 4x over, that gives me y equals negative 4x plus 6. So I'm going to take that and I'm going to plug it in for my y right there. And that's going to give me 12x plus 3 times negative 4x plus 6 equals 18. 12x minus 12x plus 18 equals 18. You might see where that's going. My 12x's go away. I'm left with 18 equals 18, which is a true statement. So if we work algebraically and come down to a true statement, then what we usually write is infinitely, depends on the question, infinitely many solutions. And if you want to remember this and understand it, it'd be a good bonus question on a test. Okay? This says that we have infinitely many solutions because they're the same line. So how you would write that would be all real numbers that satisfy, and you can write either equation because they're both the same equation. So all real numbers that satisfy 4x plus y equals 6. That's an acceptable answer if you want to write that. And that sums up solving systems algebraically.